Welcome to our CineGrid Community Forum. Today's May 25th. We'll have the same session again tomorrow at 10 a.m. Pacific Daylight Time. But Kunitake will only be here live today. So here's our agenda. Very simple. I'm now welcoming you. Kunitake is going to give a talk, developing a global over-the-top network of content for open exploration. We'll have, please hold your questions until after his presentation. We have blocked out plenty of time for Q&A and open discussion, and then we'll wrap it up at the end. So with that, I'm going to turn it over to Jeff. And Jeff is going to give us a little primer on the some of the vocabulary and concepts that will be discussed in Kunitake's talk.
Very quick introduction to graphs and networks and their key concepts to help lay a foundation for Kunitake's talk. So what is a graph or a network? They're actually mathematical structures used to study pairwise relationships, and that's important, pairwise relationships between objects and entities. Graphs have vertices or nodes and edges or connections. And the word graph and network are often used interchangeably. So you may hear both. And they're represented with G for the graph, and it's made up of vertex and edges, V and E. Graph theory was first described by Swiss mathematician Leonhard Euler, whom you may have heard of, when he considered the problem of the 7 bridges of Königsberg. No one had ever found a solution to the challenge of visiting all 4 islands, but crossing only once each bridge. And his formulation of this problem founded a whole new approach to solving mathematical puzzles, especially for those with a topological element. Now, there are different types of graph. The most common or frequently seen may be the undirected graph, and that's where the relationships between the nodes are bidirectional without the implication of flow from one to the other. So the relationship is reciprocal and remains so. The next is a directed graph, and that's where the relationships of the node is unidirectional, going from one to the other in an ordered fashion. And you see like a workflow document or a that's a kind of directed graph. And they can still represent reciprocal relationships, but 2 edges or 2 connections would be required. Then the third type of graph is either a directed or undirected, but it's weighted. So it can have a quantitative value reflecting a property of the connection. So in a network graph, you might see connection speed as the weight for that type of graph. There's other aspects of graphs that make them very interesting. One of them is the degree of a network, and it describes the number of edges that connect to a node. Nodes with more connections could be considered to be more important in the structure of a graph. So in this example, you can see that the node 5 is larger and a different color and in the center as a way to highlight that. So analyzing the structure of a graph or the visual presentation of a graph is one thing that we can do with a graph. Now, what makes graphs particularly useful for computers is that they can be represented in matrices. And so you can see we have our undirected, directed, and weighted graphs, and each one of those have an associated matrix that can be used in analysis. So they're visual, but they can also be represented in a purely numeric fashion. Other features that are commonly used for analysis are shortest path. And of course, that makes sense. How to get from A to E. Maybe you go through B, C, and D. The centralities, those are related to scale-free networks, which I'll talk about in a moment. And the idea of centralities are where some nodes have more connections than others. They might form the edge of a cluster where they connect to other clusters, or they might be central to the graph structure itself. The transitivity relates to the presence of tightly clustered nodes, clusters or communities. These clusters are more internally connected to themselves than other clusters. And this can indicate sameness or similarity. And that's something that's really important to remember as we hear Kunitake's talk. And finally, you have this idea of scale-free networks. And these are hub and spoke networks like you might observe in air travel. And these kinds of scale-free networks can have their degree distribution plotted. And this is a really important way to analyze graphs. So that's all I have to say about graphs and networks at the moment. Today, I think you're going to be much more intellectually pushed by our next speaker, who is Kunitake Kaneko. Professor Kaneko is an associate professor in the Faculty of Science and Technology at Keio University. He specializes in application-oriented networking, distributed network systems, and digital archiving. He is, as many of you know, a longtime CineGrid contributor who is famous in our community for his impressive demos and innovative applications. So I'd like to welcome Dr. Kaneko, and you should have the ability to share your screen, and off you go. We see your screen. Yeah. Oh, no audio though. Hold on.
That's my issue. It's fine.
That works now. Yep.
So I have two levels mute buttons. One is a Zoom level, and then another level is a microphone level. So anyway, thank you very much for the introduction. Thank you very much for the introduction of the graph and also the introduction of myself. Today I want to talk about the graph system. So the title is like this: developing a global over-the-top network of content for open exploration. So I'd like to start from the video that was created in Keio DMC in 2017. That is originally intended to for the demo video or the concept movie for the museum in Keio, because the Keio, how to say, at that time, Keio wanted to have a museum, and now actually it is already built. Unfortunately, this concept of video did not, used for the actual museum. However, I still think about the idea for exploring the information. So it means the video says, that is a museum. The context of the video is a museum. However, I believe it can be used for any of the information. So let's start the video.
And Kunitake, please mute your video when you play it so that I can give the English narration.
Understood. Okay. So, but I don't know how. Oh, okay. Yeah, I know. So now you can see the black screen.
Black
fine.
screen.
Black screen.
So, okay, here we go. The audio is muted.
So this is the Dmc Concept Movie, originally produced in 2017, introducing the concept of a new generation of museums. One of the advantages of making the collections of history museums and art museums digitally accessible via a website is that users can then browse the digital collection utilizing keyword search to focus in on what they want to find. But for keyword search can be difficult for people who don't already know enough to get where they want to go, or for people looking for fresh ideas. Currently, many of the so-called digital expositions that are held in museums and galleries don't go beyond using digital content as secondary support for the physical content being exhibited. The DMC Research Center is aiming for a completely new form of digital museum. Today, collections of the world's museums can end up buried in warehouses, undiscoverable, in dead storage. But what if these collections could be exhibited fully digitally without spatial limitations? Each piece in the collection could be encircled with a variety of contextual links leading to related items, presenting a world that each individual can search and interpret in their own way. By surrounding items in the collection with diverse content and connecting everything in a new type of digital catalog, content could become discoverable in ways that could not be reached by keyword search alone, with deeper understanding and insight. DMC's goal is to interconnect content from museums around the world in this new kind of digital catalog, creating a universal museum based on contextual networking, which anybody can configure content to make their own digital exhibition rooms for private viewing or open sharing. Currently, DMC researchers are working on contextual networking as part of the development of a catalog system called Mosaic, the Museum of Shared and Interactive Cataloging. We are especially investigating how catalogs can be visualized and expressed in a virtual exhibition room, as well as the implications for archiving such digital collections.
Thank you very much. The live translation. So, can you hear me?
Yes.
Okay, good. Okay, back to the. So, in 2017, when I made this video clip, I saw that we handle the graph you saw on the video directly by humans, so human manipulations, human operations. However, after the research of that, it's really hard to handle all the information. And then I noticed that we need to change the way of thinking. It means using the computational power to analyze the information before the human beings involved. So the question here is, can AI cover all the files in the world? In the video, you saw the the bottom figure like this. How to now? Oh, I don't know. So here you can see the image, right? And then I'm now thinking that all the contents here is a kind of a limited number, kind of a potential contents that she wants to know. So it means in the world, so the many files I calculated from the how many storage we need in the future now, and then divided into the regular file size. And then it seems that, I don't know, nobody knows the exact number. However, it's roughly 44,000 trillions of files. So I'm now thinking that among those 44,000 trillions files, I want to have some candidates of the content I want to see, right? However, the current technologies of AI cannot handle this number of files. Usually, actually I showed it at maximum or at most. The AI usually do the training phase, and then the training data is about millions. Okay, so the millions, billions, trillions, and then 44,000 trillions. I forgot how to say in English, you know, the 1,000 trillions. Maybe it has a better description. However, it's how to say it's totally different order of the number. So and also, if AI analyze this number of the contents, it means CPU needs to read all the data. So when thinking about that, it is totally impossible, right? And also, as the video says, the information here is a kind of, here means that here is a kind of potential content. When we put in some keywords into the system, in the search engines, you can get the content that include the keyword. It's very narrow-scopic content. You know the content, so you know the keyword, and then you can get the content. It's not the information I want to have. I want to have the information that I don't know. So I can't expect any keywords about that. So how do we do about that? So the 2 points I'm now talking about. One thing is how to get the potential content that you don't know right now. And then how to realize it with AI, you know, from the computational viewpoint. So here is a kind of a brief summary of the difficulties. It contains the difficulties I just explained, and also several more. So so for example, some of the university students got some ideas about AI technologies, and then, hey, okay, this is interesting. It's a clever idea, right? And then once you have the startup. However, how do they get the content for the training? Right now, content holders, actually, each individual has our own contents, but do you really want to share the contents to the people, to the students who want to do the startup? Even you can say yes. How do they know you are happy to provide the contents for them, right? So it is a big barrier to use a content or to start the new content services using the content. That is one point, very big issue. Another thing, okay, you have a good database. You have a kind of a metadata, right? And then well organized. The students who want to start a startup, access to your database. What is this key? What is this value? If they need to gather hundreds of they need to access to the hundreds of the contents owner, they need to repeat this process again and again and again, because the database is very, very private usually, and then it is hard to get the consistent, the database level access. So another approach that is making a dictionary. Hey, just for the same, uniform dictionary, and then all the database should follow the rule. Actually, this approach was taken in last 10, 20 years. Define the words, define the meaning, and then share the precise meaning over the world. Do you believe it is possible or not? It is usually said that that is a schema making issue, right? So I know many activities that have the issue. Okay, among small members, working fine, making a rule, deploys a rule, and then follows the rule. However, the scale of the community is bigger. Consistency will be losing, and then inconsistency, and then precise finding is impossible. Even within the small, the community like you, do you have a consistency in your directory hierarchy in your computer? Maybe just remember 10 years ago. For example, at the time of the CineGrid, I made a lot of folders. I can't understand why I made this hierarchy of the folders. It means the meaning is changing time by time, and then the consistency of the meaning is very difficult, and then I can say impossible. The third point is the content access. I just mentioned that the permission is important, right? And also the bandwidth to release the data at the computer. Intel said that the bottleneck is an interconnect, server interconnect. That is a bottleneck. It means within the computer, once the data is in the computer, they can process. However, if the data is outside, that is the usual case. It's very tough work. So reading the data is a bottleneck right now. So all of the detail, the difficulties, understanding all of the difficulties, I'm now thinking about this approach. In between the service and the content, I want to insert a network mechanism. What is the essence of the network? Network function is a binding of things. It's not a tightly binding, tight coupling. It's a loose coupling. And then it will create the flexibility between one side and the other. So in this case, the service and content. In the startup example, new service and the existing content that is located within a different organization or the silos. Inserting a new network mechanism in between the service and the contents, it's realized the easier scalability because it's not a tight coupling. So it means, for example, the meaning level, one organization have this dictionary, another organization, this dictionary, those dictionaries are different. I'm now talking loosely coupling. So I don't mind the difference of the dictionary or the difference of the relation. I don't mind. Connectivity, that is the most important thing. Then thinking about that, the easier scalability, more flexibility, and also the lighter weight computation. That is the benefit. The cons, of course, inserting a networking function in between the service and content, it means it might be imperfect service. Just imagine the internet 20 years ago. It is very hard to do the IP telephony. Now we have here in Zoom with video, it's wonderful. Now we can say this system is far beyond the telephone network. However, 20 years ago, it's not, right? And also, it's not a, maybe the, how to say, in the meaning, it's a little bit, different from what you want. But I think, I believe, it will be working. So here is a more detailed explanation of my system. I called it the graph system because the key or the core of the system is the graph. Okay. Please look at the left-hand side here. So here is the silos 1, 2, 3. Each of the silo has a content. This is actual content. This is a service layer which handle the actual content. My system is here. There's no actual content in this layer. Okay. So briefly introduced, here is a content. Here is a virtual file. This is a kind of a interpretation of the content, a kind of abstract of the content, right? And then here's another level, the circle. This is a catalog. This is a kind of a grouping or classification of the information. So in this case, the bar chart right here is a node, and then this we say get the catalog is the edge. Okay, so the grouping node here, and then if we can uniquely identify the same bar chart file like this, then we can get together and then making a graph. It's a bit different from your regular or ordinary graph. The mathematically it is a hypergraph, but I will explain about that later. So here is a graph, and then making the graph analysis using the graph here, and then calculate, and then get bar chart files. That is maybe important for the people. So after getting the candidate here, many files here, graph representation, using the graph representation, calculate or analyze the graph itself, not analyze the content itself, analyze the graph topology, and then get the more important nodes. And then using the information, retrieving the contents from the original content holder, and do more content-wide analysis. Or this service entity will analyze the behavior of the human beings, and then this is a good content for you, maybe. So this is a hierarchy or the inserting, the layer here. No content analysis, just a graph analysis. And then the graph consists of this bar chart file, that is a vertex, and then the catalog, that is the edge of the graph. You can see the layers here, content storage archives in the bottom, the graph, catalogs, bar chart files, and then graph analysis engines, that is third-party developed, and then more and more coming, right? any new coming graph analysis engine, that is welcome. And also maybe more than that, more numbers of the applications on top of it. This is a layer. So who makes this network? At the bottom, it's very easy. The content owner has their own contents. The graph level, interpretation of the content or the classification of the content, classification of the virtual files. That is a contribution of the person who is familiar with the content. Okay, maybe you have some hobbies. You're not a professional, but a semi-professional about that. So those people will contribute to create those interpretations and the classifications. And on top of it, graph analysis. Content owner wants to do that graph analysis for the users. Third party, welcome. User community, anybody can join. And on top of it, the top level, anybody who wants to analyze the contents, user context, or there's any relations, that is fine. So why I took this graph approach? Because there is a very huge area, academic research area of network science. First, it is totally different order of the processing compared with content analysis itself. Because the graph representation is a node ID, the pair of the node ID, that is the information. How long that node identifier, even that is 1,000 bits, not a problem, right? So, and also the important thing of the graph is computer can process directly without thinking any meaning. Okay, so computability, I don't know that is a good correct English terminology, but the computation, automatic computation is very important because the users of this graph is computer. Okay, so not the World Wide Web. World Wide Web, it has a hyperlink. It is a graph topology, actually. It's a directional graph. But who manipulates the graph? You read the homepage, you decide which link to follow. Okay, it means that human beings, it needs a human being's brain. I'm not thinking computer will do this kind of job, but no thinking about the meaning. So my idea is a network science, but that is any data relationship form a graph. Okay, so based on this idea, and then based on the academic knowledge about the network science, I will transform the network science to the engineering field. Okay, it's a very thick book, network science. It's totally this thickness. Okay, actually this is Japanese translation, so you can get it the English original. So okay, our graph system design principle. Maybe I need to speed up, otherwise, you know, I cannot speak to the end. So our graph design system principle. The graph system, my graph system, don't miss any potential content. That is the important thing. Okay, don't aim to find the exact content you want to, meet, right? It means the AI is now focusing on the fine-grained content filtering. But my idea of the network, this network, is a coarse-grained before fine-grained AI. Okay, so it means inserting a layer and then coarse-grained filter and then keeping the potential contents and then show it to the fine-grained system. Decentralized system that is ownership-based because anybody can create the vertex in the bar files, I say, and in the catalog that is the H, and then it's free to make. Okay, and then it's not the public. It would be the public use, but the ownership is very important. And then that is because that is the asset, because that is the interpretation, that is the intellectual activities, the result of the intellectual activities. Each individual interpretation of the contents, each individual interpretation of the classification, right? That is sometimes or usually that is a private activity. It means user dependent. Okay, so I want to realize the sheer multiple interpretations. Some of the interpretations might match with you, but some not, right? So that is the meaning of the less rigid organization, but sheer multiple interpretation, but that is fine because that is a coarse-grained filtering. Lightweight processing that I explained, the graph processing is lighter than the content itself analysis. So the graph, more detail about the graph. The graph is a global network of content. That is the title of this presentation. Hypergraph, that is this type of the graph. Jeff explains this type. This is ordinary, but this is a kind of a generalization of the graph by the mathematical people. And then there's a non-property, because if the non-property means there's a non-property definition of H. So for example, the Facebook case, this is the friend link. Okay, I don't define these kind of things. Any relation is fine, acceptable. Edge is a bar chart file. No, I'm sorry. The vertex is a bar chart files, and the edge is a cutoff. Each vertices and the edges have a global unique identifier because different people will create their catalogs, their bar chart files, but we need to get them together, okay, for analysis. Undirected lookup, it means from 1 to 2 is fine, 2 to 1 is fine. Any movement is fine. It's totally different from the World Wide Web system. It's a hyperlink one way. Okay, just imagine the how do we go through all the edges if all the rows are one way, right? If the bidirectional, we can easily to walk through the town. Graph represents two levels of the interpretation, as I explained. The bar chart file is the understanding of the single contents, and then the catalog is a classification. Okay. So this is the example, maybe more easier understanding. So the current way of the metadata adding is like this: the single contents owner is here, and then the same owner creates the fixed, the metadata. That is the current way. My system here's a single content, right? The Fox owns, because this is a sound of music, and then that is open. Multiple interpretation is fine. So somebody, this guy, titles, name it World War II in Austria. Somebody else who are interested in 8K capturing, remastering, because the sound of music, the beginning, that is 65mm films captured. Maria's version, that is another interesting point of this movie. Do Re Mi song, you know that? So the different aspects. And then if we have the narrowed title of the content, then it appeals to different users. Okay. So the budget file, how we realize it, like this, it's like a regular file, that kind of a packaged, everything inside a single package. It has a title for the understanding by the human, and also some thumbnails for understanding by humans. But the important thing is it has a global unique ID to identify, and also it has a pointers to the contents. Okay, and then anybody can make it, not only the content owner, but also anybody else. And then when somebody wants to publish the budget file, they don't need to open the content itself. Okay. So the next level, the classification. Oh, I'm sorry. Grouping. The catalog realizes a grouping of the budget files. Single contents. Here's the several of the budget files here, and then making a group. Okay. Each of the title, but that is for the humans. Actually, this cat number and budget file number is important for the computers. Right, maybe you can understand it. The budget file here, it means starting from the sound of music, right? Somebody understands the sound of music, makes a Maria's fashion. He or she has maybe is interested in the fashion. So another bag things. Victoria and Albert, right? Museums, tapestry, right? Making a group. So using the graph, I can get into the sound of music, for example, from the Doremi song, and then go through the Maria's fashion, and then to this bag. Okay. So how do we realize a catalog? Catalog has the global unique ID and then the list of the budget files. That is important for the computers, and then remains for the human beings. Okay, the same thing. Anybody can make the catalogs. Okay, of course, the content owner wants to make the catalog, but also you can make it. Okay. So now combine the budget files and in the catalog, you have the graph. Okay, back to the here, budget file, catalog, making a graph. So the next step is a graph analysis. The graph analysis, the input is a graph, and then analyze. Each of the service wants to analyze by themselves and then with their own aspects. Okay. You might think that if many of the people do the analysis of the graph, the result is the same. That is true if we analyze the entire whole graph. However, if we only focus on the limited area, the difference of the area or the difference of the algorithm or the difference of the kind of a key vertices, changing those information, then the graph analysis returns a different results. Actually, this is a big challenge because the usually the Facebook do the analysis of the graph. Actually, they have, right? But they are doing the global view analysis of the graph, and then it is a regular ordinary graph. They have the property. Sometimes it has a direction. But now it's a local view. We only have sometimes a sporadic, some of missing parts, right? Hypergraph, I'm thinking, non-property, undirected. And also the division. Usually the Facebook do this kind of analysis by the distributed way. However, the distributed way of processing requires a division of the graph. And then that division is a computer-centric approach. So the higher speed division, faster speed division, that is right now they are doing. However, I said that the catalog, budget file, that has an ownership, and then that is located different point locations. So it's very hard to get together, right? So the ownership-based division of the graph, that is another types of the another thing to think about. Here's a demonstration. I will show 3 demonstrations. First is a basic idea what we can do using the graph. Second video shows the different view user by user, okay? But using the same graph. The third video that shows many graph visualization, okay? So I'll go to the video. So here's a first one. So on the top, okay, so the top left, that is the user view, is a kind of a navigation. Okay, the system provides the set of the contents maybe the user might want to see. The right-hand side, that is a curator view. So curator now choose, right? And then this is the content, making the bar chart file, and then choosing set of the bar chart files, making a catalog, okay? At the bottom, there is a current graph view, and then after the curator register the bar chart files and catalog, notification coming up, and then we can see the update version, the graph here, right? We have the side by side before and after. This is before and after, okay? And then it has a link, it creates another link. So in the user view, we can see a new content here, right? So the user and the creator is totally different people, but working together, it's far away, might know each other, might not know each other, but we can make it happen. Okay, so that is a repeating of the same thing. So I skip it and then go to the next video. So this is the user by user different getting the different results, changing the here. You can see the algorithm and also the changing the favorite here. So this is a user A view. Favorite track is like this, okay, and then see the different, the algorithm he choose, and then the results are different. We're using the same graph, however, the favorites are different than the different results coming up. Okay, so he now add it to the favorites, the different results. Okay, so let's go to the third one. this is the graph view. Actually, the graph view is not the single way. So we have plenty of the graph visualization. So maybe you feel that different feeling of the information from the graph difference. Okay, so back to the sorry for the bad time management. Oh, and the auto demonstration video was created by Fujitsu. Thank you very much. So the Fujitsu people are coming here today. So I talked about how the graph is created, but that is the content-wise viewpoint. Now I show you the computer system viewpoint. So how we realize it? So the graph system, that is an ownership-based decentralized management. Okay, so for example, starting from budget file 7, so I'll go to the 7 server, and then it has cat 1, cat 4. So okay, let's see cat 1, cat number 1. So go to the cat 1 server. Where is the cat 1 server? Here, right? And then cat 1 has a list of the budget file 1379. Okay, so this is the cat 1. Oh, this is a 1379. Okay, see the budget file 1. Okay, so go to the budget file 1 server here. Oh, it has a cat 1, cat 2. Okay, let's see. Cat 1 is like now we have already. So the cat 2. Let's go. Cat 2 is here, budget file 1, 11, 12, or 1, 11, 12, like this. So each of the servers here are ownership based, like a mail servers, based management. And each of the servers has a list of the budget files, or the this the budget file to the catalog, or the catalog to the budget files list. Okay, and then combine those things, and then making this entire graph. Actually, one by one, just spreading outside. So that is a system here, the dark green, because this is a graph system. On top of it, distributed the third-party graph analysis engines and applications here. And then at the bottom, there is a content servers. Combine all those fours, we can make these kind of things. And then I want to make it on top of the Node.js. Okay, learning by doing is the motto or the philosophy of the CineGrid, I believe. So make it, and then learn it, and learn it. That is what I want to do. But it's totally a huge system, honestly. So I want to call for collaborators who wants to make applications, AI applications, who have the content, who wants to develop that graph algorithm, who wants to visualize a graph, who analyze the content, monitor the graph growth. It's fine, it's interesting. Managing the archive storage, access control, or the security, that is very important because this is an information network. The global unique identifiers, many identifiers are proposed right now for the data, but which one is better? Anything else is fine, okay? So that is an ecosystem. This is a final conclusion. Starting from how to let AIs work on top of 44,000 trillions of files. I said that coarse-grained filtering by network, or the flexible binding between the content and the service, that is important before getting those contents into the content AI. I believe that this graph approach using the budget files and catalogs will allow us to do what only Google can do, that you believe right now, today, and more, because we have third-party enrollment. So thank you very much for the talk. And I'm sorry about the longer talk than expected. Any questions? And also, if you're interested in, just feel free to contact me. Thank you very much.
Thank you very much, Kunitake. And if you would release your screen, please.
Sure.
Hi, Kunitake.
Okay. There we go.
Yeah, it's very clever and a very good way to handle, the so many, immersive, so much large, data all over the world. Yeah, I think this reminds me something like in theory, everybody, you have a connection with another one through like a 4 or 5. I don't remember exactly the number. So there exists the relation between any two people through the other, 3 or 4. But maybe you don't know. But your way, I think, is a very good way. It's like a naturally accumulated, tagging system to make this, easy to. Because if you want to know whether you can know the Lauren, for example, 20 years ago, or later, maybe somebody in the CineGrid, but you will definitely find there is a way to find in the notes to reach that guy. But the problem is that people don't know how to find that. You cannot just call on and say, hey, who knows the next layer? It's hard. But the way you created this is actually kind of the expanded that the potential, the possibility of the connections. So I think that this definitely will work. Yeah, I think.
Thank you very much. Very good understanding. Thank you very much.
Yes, and really also although I see, although they're generate a lot because the category generations, everything will generate a lot of redundant tagging, or maybe I'm using tagging because I think it's more like a tagging meaning, but you are using like a catalog or whatever, the graphing system, but this redundancy, you already make it, as a metadata format. So it's like a very lightweight. It's almost, ignorable. Yeah.
Thank you, Chen.
Good. Yes.
Thank you, Chen. Who's got the next question?
I have a question, Lauren. Yes, of course. Yes, I'm here. So it seems like creating these virtual files would be maybe labor intensive. Do you think that you could use some traditional machine learning on content to help in the creation of the virtual files? Let's say I was the owner of a very large catalog and I wanted to publish my virtual file index, but I didn't want to have to hire an archivist to go through everything. Do you think that people will turn to machine learning techniques to create very basic semantics and for their virtual files so that this graph view can be possible?
So it's a very good question, I think. We need to build a system and then learn how it works, because how roughly the tagging are made, and then the system or the graph analysis absorb those, rough, or the cause relation. So that's the point. So maybe this is an engineering system. So it might be the trade-off, precise meaning, tagging is better, we know. However, how we decrease the effort, right? And then how still we can get this level of the quality. That is a very important research topic, I believe. So I'm sorry, I don't have the exact answer because this is still, still not actually just the beginning of this research. So,
and if I could maybe even complicate the question more, I would argue that you don't really, the value of analyzing and creating the virtual file or the vertex file or the catalog or the tagging at the content level is probably not even enough. Like, I'm assuming by content level, you generally are referring like to a file, right? It could be an image, it could be a video, it could be a text document. But all of those things really, in reality, I found that I actually don't want to know it at that level. I want to know it at a much more granular level. So if it's a video file, I want to know what's happening, throughout the entire video, right? There are different things that need to be tagged at different timestamps. If it's an image, I want to know all of the things in the image. If there's a dog, if there's a street, if there's, if it's dark, what period it belongs to, all of those things. And so I think that it's exponentially more complicated than maybe what you've described here at the content level,
Yeah, so in my reading, so at the information level, information network level, we don't have to pay attention to the difference of the format of the information. So sometimes that is a text file description, sometimes that is a video file, as you mentioned, or the image files, or it might be the sound files, right? That is a kind of the historical reason how we describe the information in a file, right? And then right now, AI research is divided into, the segmented into that format by format, right? So the information level, I don't want to have any, criteria between those in the format, differences. And then on top of that, as you already knows, very complicated, how to say, the analysis, format by format, or how do we, another filtering of the format level of filtering, and then the AI on top of it. And then here is another filter of the file format, and another AI learning here. And then get together, and then we have several information here. So these coordinates among the AI engines, that is another big challenge we need to do. So in the slide, I didn't mention in my talk, but I have two levels of the AI in the applications: the content level AI processing, and also the user level AI processing. And in the user level AI processing manages several content level AI engines, and then get them merged, or more, further analysis, or the more further understanding of the user itself, and then provide the information. That is what I'm thinking, but I don't know it works or not at this moment. I'm sorry, that it's not a question, but as you said, it is.
Yeah, I mean, I think I've used a lot of the systems, played around with those that help you at the user level, and that's not what I'm talking about. I mean, that's another interesting area, but it's the content processing part, like just with data files. Like Amazon has, SaaS services for sending a file and trying to analyze, what, like a CSV file or whatever, and analyze the individual fields in it. But it's not that good, and I don't think there is a good state of the art for like general analysis of any content type, like you have to be very, very specialized.
Yeah, but Todd, this is Lauren. I don't think Kunitake is trying to provide that or to solve that problem. From his perspective,
yeah,
there's the ocean of data in the bottom layer, and at the top, you get little bits of it, and you can analyze the hell out of it however you want.
But you need that metadata to be able to do that. And so how do you get the metadata is the question.
Yes. And so the metadata his metadata just points you back eventually to the original asset, and then you've got to pull it yourself. But I want to say that, thank you for the question, Todd, but there's a number of comments on the chat rather, that are saying, well, the question about machine learning to generate the metadata, there are people doing research on AI to automatically generate metadata because there's not enough metadata in the world, or rather it's too expensive to manually create. And that starting with existing collections, catalogs of art museums, that have worked decades to build up their metadata to be able to easily ingest that into your graph system seems like it's a good research topic in and of itself. Because they've already done a lot of this thinking, right?
So the about the metadata, so the Todd mentioned that the content analysis requires some kind of metadata, and then I didn't say we need to throw it away. It's fine, right? The metadata analysis, add some metadata with the contents, that's fine. But I want to introduce the different, layer, different purpose of the metadata. That is inconsistent, right? So once, we figure out, we limit the number of the content we need to analyze, and then the limited number of the contents using the metadata or the making additional, the metadata by reading the content itself and then, finding out that is better, how to say, the priority when we make the sequence of the procedure.
And Case, Case has a question. Case has a question.
Yeah, so I have put indeed a number of comments on the chat, but I want to point out one other thing. So what Kunitake very interestingly presented is that he actually only wants to work on the graph. I want to point out that, for example, Elsevier has done an extensive research where they look at relationships in all the medical articles they have in their journals, the big pile of journals. They looked at relationships between words without knowing what the words mean. At the same time, they look at patterns and relationships between medicines, all kinds of medicines. They have also journals on that. And then they figure out, oh, if we see here a pattern of diseases, and we know that some medicines work for that pattern of diseases, we may find in this pattern other medicines that may work for diseases in that same pattern and vice versa. So this kind of, and they do that with only looking at the structures of the graphs, not at what medicine is this and what properties does it have, but just by subgraph pattern matching. So I assume, but Kunitake, that is one of the ways you want to go into. Interestingly, Elsevier owns and operates the whole thing I just explained, and they did do a lot of research. Actually, one of those persons is now professor in data science in our institute. In your case, you want to do it in a distributed way to make it scalable. So distributed learning, distributed and federated graphs. And I think that is really a very interesting challenge.
Thank you very much.
Yeah, Kunitake, correct me if I'm wrong. So I believe, we need to change the mindset here because this is not the traditional keyword search engine. This is based on the relation of the contents. They don't care about whether you're using this keywords or that keywords or what content or what visual elements contains inside. This is purely, voluntarily by all the users, contribute the catalog, which becomes like a valuable, big data on another level of the big data to help the people find the contents they may not use in the treaty. They even cannot imagine what words they want us looking for, right? They just find, oh, this is related. Hey, it's interesting. When they go through traversal, your catalog, all the nodes, they find something they cannot imagine. They even without any keywords they can find it. That's the beauty. That's the meaning of this system. Yeah, this reminds me when I was in the graduate program, I worked with my professor, did like a non-keyword search engine. That's like 20 years ago. But I think it's something similar. It's like because we're using the pure mathematical level. If you are looking for something in the library, you don't have to give the keywords. You write a proposal. You say, hey, what I'm doing, I want to do the video. Then you write a proposal, then you hand it over to the system. System will get rid of the high frequency words and low frequency words, only take the middle frequency words because those are very related to the content what you want. Then they building a very, high dimensional, multi-dimensional eigenvalue matrix system. Then they calculate the correlation between the pairwise words. Then your proposal will be in a location of the information dimensional space. Then there's another document maybe is matching your, but they're never using the exactly same keywords, but they also calculate that one in the information space. Then you measure the distance, how far. That's the project I'm working on for the French company, oil petroleum drilling company, Schlumberger. They want to find some patent information from the Congress Library of America, but they're using the keyword. They couldn't find anything, contribute to the technology.
And so,
That's why,
Chen, I'm going to interrupt you there because this seems like a lot that you and Kunitake could talk about.
Yeah.
And you should collaborate. So I want to ask Kunitake.
Definitely.
I want to ask Kunitake, what do you need, or what can you use from CineGrid? Why do you want to be on the Nautilus system? How much? You've talked to me about the fact that your whole system requires computation and storage and networking at different stages, different levels of your process. So John Graham, is on this line, at least listening in the background, and Tom as well. What do you need from them to get going?
Okay, so when I listened the Node Trust project in the previous, the CineGrid, this forum, immediately I saw that it's very useful for building up the graph system because of that is a distributed system and in a container-based deployment. So we want to use many of the graph algorithm or the many of the content analysis engines and user level context analysis engines deployment. So what else can do that? So the container, who wants to deploy the application, making a container, just deploy, working there, and then get the results, return back to the user. So all of those things can be realized by the Node Trust that I want to use it. Is that the answer?
I think so. I guess you should, follow up with Tom about, actually getting access and maybe federating some Keio servers into Nautilus so that everybody can play. And
not only the Keio, but also any organization who wants to join this project, then just contribute some computer resources, network resources, and get connected with the Node Trust and making a bigger network, right? So
yes.
I think that that is another viewpoint, a good point of the Node Trust.
You want to take
Tom, you got anything to add here?
Yeah, it sounds like you want to take advantage of our potluck supercomputing concept to scale your catalog and your node graph. We're already using quite a bit of node graph analysis.
John, we lost you there.
Turn off your video, John.
Where's gradient graph that does.
I'm sorry, John. We've seemed to have lost you. Maybe you'll come back.
So, John, just try if you can turn off your video.
It's just intermittent. I'm fine.
Okay, so repeat what you just said because you sounded like it was coming through a long garbage can.
It was. So we do lots of node graph analysis in Nautilus already for our network analysis. We're using gradient graph from Reservoir Labs that calculates choke points in our wide area network, and then suggests changes to the routes. And so yeah, we're very familiar with graph analysis, and we're creating an interface, a three-dimensional geospatial interface for searching through these node graphs. And then a lot of data has geospatial coordinates. So you can do all kinds of geospatial stuff or throw away the globe entirely and then just do self-assembled spatial pattern recognition. And then the other concept is you take these representations and then you point machine learning at those glyphs. And then this glyphified thing becomes the subject of machine learning for pattern recognition. And yeah, so search and analysis tools are what you're presenting here. And it's a critical thing that needs to be taught in schools also. You just can't, throw node graphs at people. You got to know how to climb on them.
Thank you, John.
It's a big challenge. Yeah.
Can I add a couple more thoughts, Lauren?
Go for it, Todd.
So ignoring the data curation challenge, which I do see as an extremely formidable challenge here, pretending like we have a limited scope where that's not an issue. From an application perspective, the way I think of this is this is the modern publishing platform. Like what Chen was saying earlier, I think that paradigm shift has actually already happened. Like you look at like the way that Netflix presents information, most people don't look at it through a search interface. They look at like what is recommended to them, right? Through the different genres. Same with Amazon Prime, same with Google Maps, like everything today is based on recommendations. And there's kind of three main ways in which those recommendations are brought to you. It's based on an individual's patterns. So meaning like, what do they normally look at? What do they normally do? What are they clicking on? What are they searching? Their preferences, the things that they're explicitly saying they're interested. So in your case, the example is like you were favoriting something and then tells you the things related to that. Or their social network, right? What are my friends and kind of colleagues and peers sort of doing? So when looked at through that kind of lens of those three sort of pattern or sort of modalities, I guess, would you say that your system could support all three of those, like providing recommendations based on all three of those, or is it really not so much based on that?
So first of all, those services very well organized, I think. They focus on the service and they try to realize it, and then they want to aim the efficiency, higher efficiency to realize it, right? My goal is a bit sifted off. Okay, so that kind of analysis, I want to use it. And then I want to deploy is just remove the boundary between the content owners. Or we can say the boundary between the Facebook, YouTube, Netflix, right? That is my focusing point. So even, they have the very great, the service, great analysis, the algorithm, but they cannot find out anything out of their content storage, right? And also, if that is located outside, their analysis engine does not work well, because for higher efficiency, they tune more and more, and then they assume something before doing some processing, right? That all stacks realize the very good services. This challenge is a kind of a more loosely coupled, more rough information, and then catch up the same quality of the services. So that's what I want to do.
So I'd like to suggest that Todd and Kunitake can follow up. I'd like to leave. We have just a few minutes if there's anybody else that would like to ask a question or make a comment who hasn't spoken already.
What about Louise's comment in the chat? She had a very good comment in there.
Well, Louise, you were commenting about basically from the art curation perspective, right? Museum curation perspective, where people already have catalogs. You're muted, Louise. Your Zoom is, there we go.
Beginning to, instead of trying to do all the art in all the museums, if you just focused on a specific genre, like, French Impressionists, and had keywords like Cassatt and Monet and Matisse, and then used open source metadata cataloging applications that are out there that museums are using, that could at least be a start to get your hands around it, and then take it from there to the larger, issues that you're trying to tackle. Just a thought.
Thanks, Louise. And anybody else have anything they'd like to add?
Sorry, Elizabeth Cohen is not on the Zoom anymore, but she had mentioned in the side chat that she thought the Academy Museum and the Hibby Museum are both good candidates for this. And she said that the Hibby is the home of Big Hit and BTS. They just opened 2 weeks ago. So that was a comment in the side chat, and she's not here to defend herself.
And anybody else? Alva, you're muted. I see your mouth moving, but you're muted. There you go.
Can you hear me?
Now we can hear you, yes.
Okay. Nothing particular to add. I've been enjoying the chat. I've been enjoying the chat about the Dutch East Indies project that's data is becoming available. I don't know whether anybody's been noticing what's going on in the chat, but I thought that was great news. The VOC database.
In America, we don't learn anything about the Dutch in America. New Netherlands, New Amsterdam, and all that data, all that information has been locked up in 17th century Dutch. And it's fantastic that this is coming out. It is just, it's so
I agree.
I'm really excited.
I know that's not on topic, but I think
I know.
it's really interesting.
Well, so I'll try and bring it onto topic, actually. I'll bring it onto topic, because what Kunitake is acknowledging is that information is the access to information, the amount of information that's accessible digitally is growing faster than anyone can keep track of.
Yes.
Right. And it's growing with inconsistency and in silos and in private this and in public that. And how can you find what you want when you don't know what it is? Right. And also, how can you filter, how do you boil the ocean down to find the pearls in the bottom?
So
right?
I have a question for Kunitake.
Go ahead, John.
Have you considered the use of a client-side agent to consume the product of your node graph analysis? We're looking at agent technology to allow us to program it with our search trees, our preferences, then on our behalf go out and look with filters at the massive flood of information. So there's both the server side and the client side, and agents, artificial intelligent agents is another technique you can use.
Yeah, exactly. So so I started this project at the research with my students with the technology of the client side. So it means the client gather all those, the graph information, partially, distributedly managed, and then get together an analysis here. And then I'm now shifting what we can do with a distributed, you say that the agent based. So each of the Barja file servers or the catalog servers has some agent there, and then calculate at their own, and then the results get them merged. Okay, so it's one level up, gathering of the information. So that is more, efficient because the graph gathering is taking time. It's really taking time. So we need to think about that more deeply. Thank you very much for the comments.
I think you need to add considerations about privacy, security, and so on, because just sending out information gathering agents to everyone and hoping that they install them within their domain is kind of tricky. So you need to consider also privacy and security considerations in these.
Yes, I believe that you can do that part. Because in the call for the collaborators, I have a line of the security or the access control that I believe very, very important. And then the idea of this comes from the internet philosophy, actually, just changing the computer resources, the network resources, regular electrical to the information level, and then changing the ARD and apply the same thing. And then I'm also thinking about the security is a missing part because the internet doesn't have any security mechanism and then these terrible things. So we need to pay attention more about the security internet.
And so this is a very interesting presentation, Kunitake, and as expected, as simulated a lot of conversation, Gene Miller, who's on this call, has written in the chat that maybe we need to decide on a killer app or a killer domain or a killer community, too many killers there, but a target to start, someplace to start. And we are right at the end of our allotted time, and I'd like to just close out with this slide. Let's see. I have to make myself spotlight. All right, if hopefully you can all see this, and we just had Kunitake. This is the calendar for the next few months. Next month, June 22 and 23, we'll have a really good talk about Sage 3, AI, and the next generation of remote collaboration from Jason Lee and Luke Renenbo, who most of you already know. They've just gotten another big NSF grant to develop the third generation of Sage, and they're anticipating AI in their thinking. In July, on the 20th and 21st, we'll have a three-part talk, actually, on advanced imaging technology to reveal secrets hiding in plain sight. Mark Ellisman is a world leader in microscopy and information research for imaging. And Ilke Altinas is the Chief Data Science Officer for San Diego Supercomputing Center, who's been a pioneer in what's called composable systems as a infrastructure architect. And Matthew Madani is a researcher at Mark Ellisman's Institute, who's going to talk about a specific case study that he did computing, using AI and image processing to handle a teravoxel, 1,000 by 1,000 by 1,000 volumes. And then on August 10th and 11th, Alvy Ray Smith, author and co-founder of Pixar, will present from his new book, The Biography of the Pixel. He's been working on this book for several years, and its publication date is August 3rd. And we'll be having a book opening with Alvy, and we're very pleased that he's agreed to do that. We're working on other calendars for future months. And we're still looking for CineGrid 2.0 project proposals. Essentially, Kunitake has laid out the first proposal. Thank you so much, Kunitake. And if you, the community, think it's worthwhile, then let's start collaborating. But if you have your own idea, please send it to Jeff Weekly, and we'll certainly take a look at it. I am very happy to welcome so many of Kunitake's colleagues from Fujitsu, and many of us have had long collaborations and productive relationships with Fujitsu in the past, and we certainly welcome you to participate in CineGrid, and we hope you keep working with Kunitake to make this really innovative approach a reality. And I think that's it for today. I certainly want to thank Aoyama Sensei for coming out of retirement to be here this morning. It's coming up on, I think, 7:30 in the morning in Tokyo. So Ota Sensei and Kunitake and all the people from Fujitsu, thanks for waking up so early. And those of you in Europe, Case Delot in particular, thanks for staying up so late. And those of you who want to see it again, we'll be posting the video for you to watch at your leisure, or we're going to have another session tomorrow, same presentation, different people. So thank you very much. And we're at 5 minutes past the appointed time. So I want to thank you and I want to adjourn.
Are being used today to tag content at certain levels around key thoughts and words and concepts. And in fact, there's some industry ontological efforts to define some basic building blocks. And I'm really interested and in fact, working on some aspects of deep content discovery and search. It'd be interesting to understand what a controlled vocabulary might do to enhance the capability, in addition to the randomness of either crowdsourcing or the machines looking at the unique relationships, and whether having a controlled vocabulary as an input is an advantage or a disadvantage in this system.
Well, I'll take that one, Lauren. I think for people creating the virtual files themselves, a controlled vocabulary is probably necessary. And you can think of it as a veneer on top of whatever systems that they're currently using. It is not, however, necessary for the graph system that Kunitake is proposing. In fact, that's a big advantage of this, in that it will allow various controlled schemas to coexist quite nicely. And there may be points in the graph where they connect node to node. You say, pony, I say pony, Lauren says little horse. But that pony to pony connection, it will link your content to my content. And then the system, by way of graph analysis, may find other links like that. So I worked for a number of years at the Naval Postgraduate School trying to enforce metadata schemas around operations research and resources, so we could describe them in virtual environments and use them in simulations. Impossible. The military has about 16 different ways to say where you are. There's 4 or 5 different ways to say what time of day it is. And so we always hit that wall where we couldn't get anyone to agree that my metadata is better than your metadata, is worse than his metadata. So this system lets you pop above that. And by doing a graph analysis that is agnostic to schema, you still have a way to do analysis. Does that make sense?
Yeah, and obviously I see a world where there absolutely needs to be some controlled ontological concepts around especially content-related metadata. But if you start to think about maybe a deeper search engine, if you will, with a body of constrained content, that maybe user input can help discover new relationships between that body of content. But it really probably starts with something that is constrained, because libraries today are in the process of being tagged in various ways. And so I think what was being proposed is pretty interesting, especially around then abstracting kind of the relationships through the visualization, and then understanding how the visualization itself becomes a navigation approach through the content in unique and potentially non-linear sort of ways.
There's also a lot of activity in machine learning and content analysis at the very bottom layer. That's a very active area of research right now, trying to extract semantical meaning from, let's say, a frame of an image. And so you could, in some ways, build your corpus of virtual files up from that level, or you could start, as you suggest, from your traditional, schema and the way that people derive metadata now. In both of those cases, you could publish your virtual files and make your graph, your little part of the graph, available to others to view without ever having to expose your content. So that's another advantage. You don't have to give somebody the frame to give them the ability to do the analysis.
And so the other thing, Leon, I think is, Kunitake has, he is a computer scientist. He has developed a theory that he believes he can implement. And one of the beauties of this theory is that it assumes the most minimal kind of information, but it doesn't prohibit elaborate metadata. All right, it doesn't in any way prohibit a content owner publishing metadata based upon their own uniform dictionary in whole or in part. It's just a virtual file. It can have as much or as little. And by leaving it unrestrained, he allows everybody to have different interpretations. And even within the same organization, we all know that happens. And his graph analysis, his first level filter, doesn't look at meaning, doesn't know what's in the metadata, only that somebody has taken these virtual files, created them, and cataloged them, and asserted an interpretation by grouping them. That's all that's all the graph knows. And so it could be anything. And so you can have multiple people looking at the same data, creating different catalogs, or multiple people putting different content from different silos using virtual files into the same catalog.
So what is the activity that the user is doing? Is grouping the catalogs, is metadata tagging, is some other contextual input? Obviously, there's a group of users that are doing something to enhance the capability of these graph engines. What are they doing?
So one level of user is creating virtual files, and another level of user, could be the same person or could be different, is making catalogs. And the third level of user is building net graph analysis and applying it to the combinations that result from users who make virtual files and people who make catalogs. All right, so could be three levels of users that would be directly involved in building what Kunitake is talking about. And then his vision is that the net graph analysis offers up candidates, a coarsely filtered group of candidates that will hopefully include what you're looking for, as well as other things which you might not be looking for. And you apply a second level of AI or a second level of analysis or formatting to those results. And that could be content analysis, it could be user behavior analysis, it could be your recommendation engine, and so on. It could be anything at that top level. And because that top level, you draw the original content from the content owner, then the content owner can collect their nanobuck at that stage, because the three levels of abstraction that Kunitake is proposing don't contain content. They're only numbers or some amount of metadata.
Mm-hmm.
So it isolates the commercial aspects from this network mechanism that allows the higher level of abstraction that he's proposing.
Yeah, and does it need a dispersed network as well? If all the content lived in a single server, for instance?
No. They'd become virtual servers. There's still something called a file server that holds the content, and a catalog server, and graph server.
Yeah, so it doesn't matter if it is not dispersed. They become kind of these virtual groupings within that one logical file system.
Yes, but he assumes that somebody owns the virtual files that they create.
But
and,
if you if you look
so he allows for this different people to own different parts of the ecosystem.
But if you had a constrained ecosystem where it's literally one content, like a museum or a content owner, it's one content owner's content.
Could be, certainly.
Yeah, because I definitely understand a number of kind of traditional content future-facing applications that might be deployed using that sort of deep search discovery, content navigation, and consumption.
Well, so Kunitake's proposal is, hey, let's plant this on Nautilus and make it accessible and let people put in their content and do their analysis and see if the scheme works and if it's useful. That's basically what he's throwing out. I want to make sure we get Michael Krzyk in on the discussion. Thank you, Leon.
In a last session, I wrote you that nothing rang the bell, but this presentation rang the bell. We are currently working with National Museum. In Europe, we have multiple projects which are trying to create meta catalogs, and I believe that that one of these challenges is to link those catalogs together somehow. And also there is another issue, which is different languages within the Europe. So graphing and AI may help us with bridging all this different languages scheme. This is one thing. Another one is we are working with different type of organizations that have their own connections. That they have collections that are sitting next each other. For example, Prague Film Faculty has an archive, which is, let's say, archive like bunch of tapes, and they are trying to describe them somehow. Then we have a National Film Archive, which in most cases have collections produced by filmmakers who studied at Prague Film Faculty. And then we have a Czech television that has some, let's say, recordings with those actors and then directors and camera people. So, and all of these organizations have their own ontologies. They have their own metadata schemes, and we need to connect those collections together without too much effort, just because for now the main problem with connection is not a technical stuff like I am not able to connect your film with my recordings, but bridging the ontologies. So they are able to search by names, but that's it. If someone names the new wave of Czech film, it works probably good within the film archive, but in most cases not in the film faculty, just because those filmmakers were just students, so there were no new wave that time when they have been studying. So I think this is the good way how to make their collections more usable. So I believe that we are able to work with Kaneko-san to make stuff happen, and we already have some data he can benefit from.
Well, that's great. So actually, Kunitake's joined us at 3:30 in the morning in Tokyo, and you look fresh and awake. So we've already had comments from Andy Maltz and from Leon, and now you just heard Michael Krizik. George or Donna, we haven't heard from you yet, or Arn.
Well, I was thinking about the content for the CineGrid video review, for example, that much of which was born analog has been digitized, but there's even before you get to the level of creating a catalog and a collection, that a large portion of that material doesn't even have keywords associated with it and so forth. And so there is, there are these huge collection, like what about content that does not have any digital information associated with it and so forth, and sort of the methodologies, applying maybe some AI or what have you to material that has already been digitized in order to extract metadata or what have you to make it useful for a system like you're proposing.
So Donna, this came up actually yesterday as well. The idea of using, how do you ingest existing metadata collections that because many people have curated metadata already. So how do you ingest that? And maybe there's a potential research of ML, machine learning, to ingest metadata. Certainly, I know myself of several AI research projects to automatically generate metadata of various kinds. The hard part, among other parts, is the generation of contextual metadata. Not just what is it and what's it called, but how would you describe it in a setting? And humans are really good at that, and machines are not good at that. And the interesting thing is that Kunitake is proposing a technique that is exactly targeted at, that is network graph analysis, at perceiving or using context, right? Context being all the things that you think of. So thank you, Donna. It's a really good idea. And the CineGrid Exchange archive, we can certainly contribute. It's very simple, but it's something to start with. And the CineGrid video review, we'll come back to that.
It would be, Lauren, I think it would be a very interesting experiment to take content that did have context and metadata and expose it to the system, and then strip away the metadata and use some machine learning techniques to try to derive some metadata. And they might be, it might be very different from what you have as human markup, and then compare the results. That's a validation that you could run to say it, perhaps doesn't matter where the metadata come from. You always get similar results using the graph system.
So, George?
I'm just marveling over the fact that graph theory that I took a class in college actually has a practical application. So it's taken me a few decades to get to that point. But
well, that makes you an expert, George.
No, it's fascinating. I'd love to sort of delve into this a bit more deeply. This just feels like there's a lot under the surface here to chew on.
So Kunitake, have you thought of anything that you forgot to say yesterday?
Actually, can you hear me?
Yep.
Yeah. Actually, first of all, thank you very much to join this conference. It is, the recorded, so I don't know how I missed the comments, the Leon, the Andes, and then it gets the comments, only the latter half, maybe the final part of the Mikhail Classic. So, first of all, how do you feel it? So could you give some in the brief summary, Lauren?
And I have to run a little bit, but I'm fascinated by this notion of a deep archival search and discovery and navigation at a very deep level of content libraries. And I'm working on some concepts around that that obviously start with metadata, deep metadata and controlled metadata, and interested in how that user-generated kind of context and metadata then can create new sort of connections and then visualizations that could be navigated with an interface in multiple different ways around how you discover and search content. So I was fascinated by the concepts, especially this notion of decoupling the metadata from the content necessarily, but not necessarily, and then understanding just what those systems really look like, and how to begin a process where to understand how this engine might work. But I thought it was a fascinating discussion, and it hit a number of topics for me. Unfortunately, I have an 11:30 meeting. Would love to continue to understand where this work goes, and maybe have some discussions with some of my colleagues around some of the work that I'm doing.
So, Leon, before you go, and because we are on time, I want to just share the final slide. So here we go. Where'd it go? I don't know what system I'm in. Sorry. Zoom.
While Lauren's finding that, Kunitake, if you can stay on for a couple of minutes, we can fill you in on what people said. If Michael wants to stay on, and Andy, or if you have to go, we'll let you know what the other comments were.
Here we go. Sorry, found it. So thank you for Kunitake. I just want everybody to know that in June 22, 23, we're going to have a talk about SAGE. Luke and Jason and the teams in the University of Hawaii, University of Illinois have gotten another round of NSF funding to do third generation of SAGE. And they're going to talk about how they think about AI in the context of remote collaboration. And in July, we have a talk from the world leaders in microscopy and data science from UC San Diego and the Supercomputing Center, advancing imaging technology to reveal secrets hiding in plain sight. And then in August, Alvy Ray Smith, who many of you know, has spent the last 5 years writing a book, The Biography of the Pixel, which is being published by MIT Press on August 3rd. And he's going to give us a book opening session and talk about his book and engage with all of us. So we are still looking for new projects. Kunitake has kind of proposed one today called his graph system. And if you have an idea, send it to Jeff Weekly. And that's it for me. Thank you all very much. And thank you for joining us.